The research question for this segment was, what does emission duration depend on and not depend on? The hypothesis we had to test was that emission duration observed in chemiluminescent glow sticks is completely dependent on energy input and completely independent of the emitting fluorescent dye. Emission duration is the length of time that light is being emitted in a glow stick. We found that emission duration depends on energy input, rate of energy output, which is affected by temperature, and properties of the dye. Since the energy input for the two dyes was the same, the amount of energy emitted should also be the same. Thus, since green dye molecules emit a higher intensity of photons per unit of time, they would stop emitting light first and thus have the shortest emission duration. On the other hand, the red dye emits photons at a slower rate than the green dye, so the red glow stick would last longer in terms of duration. This means that duration depends on the dye because the green dye, which has a higher emission intensity, has a shorter emission duration, while the red dye has a smaller emission intensity but a longer emission duration. This information supports our hypothesis because, as we can see, the emission intensity for the green dye is decreasing at a faster rate than the intensity of the red dye, suggesting that the rate of light emission by the green dye is much faster. Our results showed that duration is directly dependent upon energy. At a given temperature, the more energy in the form of activators inputted into the system, the longer the chemical reaction can take place and provide energy to excite electrons. And the more energy absorbed for excitation, the more energy released when electrons return back to ground state. However, if temperature is manipulated, then the rates of the reaction would change as well. Heat speeds up a reaction and causes intensity to increase initially, causing duration to be much shorter, while the removal of heat slows down a reaction and causes duration to be much longer. In summary, emission duration depends on energy input, rate of energy output, which is affected by temperature and properties of the dye.
This is analogous to Newton's cradle because the more energy you input, the longer the duration. In the system, the further you pull back the ball, the more energy you add to the system and the longer the balls go for. Energy is being released to the surroundings and the system is eventually stopped. As energy is released, the balls move a shorter distance away from the center one because there is less energy in the system, just like how the emission peak intensities decrease over time because of the energy being emitted.